Hello Year 10 and welcome to our first Chemistry 1 revision video. This video is going to be looking at atomic structure and the periodic table. So it's briefly going to summarise everything that we've done on this area. So getting us started, way back in Year 8 you would have looked at the structure of the atom and knowing that you've got protons and neutrons in the nucleus and those electrons whizzing around the outside in their orbits. Now, what you would have learned this year is your electron number, so the number of electrons and the number of protons are balanced in an atom. Okay, but we learned that there are then exceptions to that. So, in terms of atomic theory, what do we know? All matter is made of atoms. Okay, they're neutral, there's no charge, and they're made up of these protons with positive charge, and we say that mass of 1. Those neutrons, which have no charge, again, we say the mass is 1. And then we've got the electrons that are negatively charged, and their mass is tiny compared to that of a proton. Okay. So neutrons, neutral, protons positively charged, electrons negatively charged. Well, our atoms are held together by what we call electrostatic attraction, and that's that opposites attract. Your positive charge and your negative charge attract, and we'll come back to that later with metallic bonding. Okay, now we have heard, as we've talked about the periodic table, about this concept of the mass number, and the mass number is the number of protons and neutrons. So basically the number of those subatomic particles in the nucleus added together, that makes our mass number. We have our atomic symbol, that's the letters that you use to represent the element that we're looking at. So here, for example, is carbon, so that C is the atomic symbol. And then we have the atomic number, which is the number of protons, okay, and our periodic table is arranged by our atomic number. So here we've got carbon, we know the mass number of carbon is 12, that means and our atomic number is 6, which must mean carbon has 6 protons because it's the atomic number, and must have 6 neutrons as well because our atomic number plus the number of neutrons will equal our mass number. So again, we've got carbon and we're looking at that atom of carbon there, that representation, and then we've got carbon as it appears on the periodic table with our mass number, the 12, and the atomic number, the number of protons or electrons, but just remember as we get to ions that changes, so it's that number of protons for our atomic number. Alright, then we moved on to look at this whole concept of electron shells. Now I talked about electrons whizzing around the nucleus. They do so in a very specific order, okay? And we have different electron shells and they hold a different number of electrons in them. So the closer to the nucleus that the electrons are, the lower the energy that they have, and they then hold very, very tightly to the protons. The further away they are, the further shell they are out, the easier they are to lose as such. Okay, so electrons in the outermost shell, they have the highest energy and are very, very loosely held to the nucleus. The maximum number of electrons a shell can hold, now this is one thing we need to remember, okay, is we say that 2n squared, okay, so the maximum number of electrons, we say 2n squared, n is the shell number. So if you're looking at shell number 1, you'd be saying 2 times 1 squared, okay, and we look at that on the next slide very briefly. Okay, so if we're saying shell number 1, so n means shell number 1, okay, we'd be saying 2 times 1 squared, and that the answer to that's 2, and so on. All right, when we look, now we've looked at atomic structure and we've got the idea of those electron shells, we now need to start looking at the periodic table. Okay, so here's a picture of the periodic table, and we know we've got our transition elements in the middle and our main groups to either side. Okay, here we go, another view, and this is some information here that's quite important in terms of where our metals and our non-metals are. Remembering, if we're doing metallic bonding, it's going to be between metal atoms. If we're doing ionic bonding, it's metals to non-metals. And if we're doing covalent bonding, it's just between the non-metals. That's why it's important to understand where things are on your periodic table. Now, what does the periodic table actually show us? Well, it's a list of all the known elements in increasing atomic numbers. So as you move from element number 1, which has 1 proton, through, okay, you are increasing in the atomic number. Now we've got 2 different ways that the periodic table is laid out. We've got what we call periods, the horizontal lines. They're labelled, so horizontal, that is parallel with the ground, okay, horizontal. They're 1 to 7, periods 1 to 7, and they indicate how many shells are being filled with electrons. Okay, so everything in group 1 has 1 shell, period 1 has 1 shell. Everything in period 2 has 2 shells. The groups, which are vertical, up and down, they're labelled 1 to 18, and they contain elements with the same valence shell electron number, so the same number of electrons in their valence shell, the valence shell being the outer shell. Okay, so let's have a look. So these are the groups. So group 1, which is our alkali metals, they have 1 electron in their valence shell. Group 2, which are the alkaline earth metals, they have 2 electrons in their outer shell. We go right along to group 2, their outer shell is completely full. Okay, these guys, they can add 1 more to their outer shell. Okay, so it just depends on their numbers as to how many shells they've got in terms of how much it will fill their valence shell. But basically 18, their valence shell is completely full, the outer shell is completely full. Group 17, they can add 1 more to their outer shell. Group 16 can add 2 more to their outer shell, and so on. The rows, this is looking at how many valence shells they've got. Okay, so the period, so the top period 1, they have only 1 valence shell, so only have 1 electron shell, sorry. Period 2, that has 2 electron shells. Alrighty, so if we look, these helium and hydrogen and helium have 1 shell. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, they have 2 shells. If we look down the groups, these guys all have 1 electron in their outer shell. These have 2 electrons in their outer shell. These have 3 electrons in their outer shell. So number of shells, horizontal. Number of electrons in their valence shell, vertical. It's just showing the different types of elements on the periodic tables, the different groupings. So you've got your alkali metals, your alkaline earth, your transition metals in the middle. Post-transition, don't worry too much about them. We've got our semi-metals, we've got our noble gases, extremely unreactive at the end there. Our halogens, a little less unreactive. All right, just a quick bit of revision on ions, and then this video is done. So a neutral atom has an equal number of protons and electrons. If an atom loses electrons, it becomes a cation. It becomes positive because it's got more protons. Okay, so that's our metals, the cations. They lose electrons and then they have more protons. Anions, they gain electrons. They take them on, so now they've got more electrons than protons, so they have a negative charge, okay, and they're generally our non-metals. They are our non-metals. Okay, and we've got some common atoms and their ions. We have sodium, which is a metal, has 11 protons, 11 electrons in its neutral atomic form. When it's a sodium cation, it's lost an electron. So it's got more protons than electrons, so it has that charge of +1 because there's more protons. Chlorine, that's the balanced chlorine atom. The chloride anion has 17 protons but has gained an electron, so it's got a negative charge because it's got more electrons. That is all for this revision video. Hope it's been useful. I'll see you in the next one, which is on types of bonding.